Listen to the sounds that you hear all around you. Do you think all these sounds are the same? No, right? They are different. Now, what do you think makes these sounds different from one another? Let us find out how sounds are distinguished from one another. Observe this animation. Here, the cymbal of a drum is being hit softly, and thus we are hearing a soft sound. Now, what do you think happens if we hit the cymbal harder? When the cymbal is hit hard, we are able to hear a louder sound. So the thing might not be clear to you, right? Let us take another example to illustrate the same concept. Here, a string is taken and is tied in between two fixed ends. After that, a force is applied on the string with a finger. Now notice what happens when you apply a gentle force. When a gentle force is applied, a soft sound is heard. Now what do you think will happen if we apply a larger force? If we apply a larger force, you will find that a louder sound is heard. So what do you think is happening? In both cases, that is the cymbal of the drum and the string, you find that whenever a greater energy is being supplied, a louder sound is being produced. So what do you think is happening? You will be interested to learn that loudness of a sound wave is related to its amplitude. Let us take a quick recap of what amplitude was. Amplitude of a sound wave is when the disturbance is traveling, the displacement of the medium particle on either side of its mean position. So what do you think happens if we apply a greater energy? When a greater energy is applied, the medium particles will vibrate more. So when the medium particles are vibrating more, that is, their to and fro motion about the mean position is more, obviously it results in a greater amplitude. So let us find out how loudness and amplitude are related. We find that a sound wave which has higher amplitude will produce a louder sound, and a sound wave which has a lower amplitude will produce a softer sound. As I said, the amplitude is the displacement of the medium particle on either side of its mean position. As you can see from these animations, in the first case, the amplitude is higher, and thus the sound being produced will be more than in the second case, where the amplitude is lower. Now I have a question for you. On the screen you find there are two waves, wave shown by figure A and wave shown by figure B. Can you tell me which wave will produce a louder sound? That's right. Louder sound will be produced by the wave shown by figure A. Why? Because as we just learned, the loudness of a sound is related to its amplitude. The amplitude of wave A is much higher than the amplitude of wave B. That is the displacement of the medium particles on either side of their mean position. So as the amplitude of wave A is higher than that of wave B, wave A has a louder sound. Now on the screen, you will find there are several instances along with their respective loudness given. Now, how do you think loudness is measured? Loudness is measured in terms of a unit called decibel, that is shown as dB. Now, as you can see, when a pin is dropped, the loudness is roughly or nearly equal to 0 decibel. This is where the phrase pin drop silence came from. In the case of leaves rustling, the loudness is around 10 decibel. For a soft whisper, the loudness is around 30 decibel. For a normal conversation that you have with your friends or your parents, the loudness level is 60 decibel. When a car or a motorcycle starts up and moves, the loudness level is around 80 decibel. And when a jet or a plane is taking off, you hear a very loud sound, right? In that case, the loudness is 150 decibel. So as I mentioned, this loudness is related to the amplitude of the sound wave. As you will recall, in the previous cases of the string tied between the two ends and the cymbal being hit, in both cases when a greater energy was being supplied, the medium particles was vibrating with a greater amplitude. When the medium particles vibrated with a greater amplitude, the sound that was heard was louder than when the medium particles vibrated with a lower amplitude. Now take a close look at this animation. Here you find that a man is bringing a piece of paper near a candle and the paper is burning. Now notice what happens if we perform the same experiment with a slight twist. Here, a paper is being brought, but it is held at a distance from the candle. When it is held at this distance, you will notice that the paper is not burning. Now, why do you think it is happening? We are using the same candle in both cases and similar kinds of paper. So why do you think it burnt in the first case but not in the second case? Let us perform another experiment to illustrate the concept. Here you will notice there are two men standing at a distance apart. A bulb is dropped near the first man. You will notice that when the bulb falls and breaks, the first man is able to hear the sound of the bulb breaking, and that is why he reacts. But the man who is standing at a distance apart is not able to hear the sound of the bulb breaking, and that is why he does not react. So why do you think this is happening? Why do you think that the first man is able to hear the sound but the second man is not? Let us find out. To understand this concept, we need to learn a new term known as intensity. What is intensity? The sound energy carried by a wave per second, normally per unit area, is known as intensity. So, the sound energy that is carried by the wave normally per unit area per second is known as intensity. Let us clarify this concept a bit more. On the screen, you will notice that an area has been taken in the medium through which the sound waves are traveling. This area represents unit area. Now you will see that the sound waves that are traveling are passing through this area normally or perpendicularly. So what did we define intensity as? Intensity was defined as the sound energy that was traveling through unit area normally in 1 second. So in the previous case, in the animations where you saw that the candle was able to burn the paper that was near it and not the paper that was far away from it, it was because when the paper was near the candle, the intensity of the heat was more. Similarly, when the bulb was dropped and the person near the bulb was able to hear the sound and not the person who was far away from the bulb, it was again because the intensity at that point where the first man was standing was more than the intensity at the second point. Now, you must be wondering that loudness and intensity might be connected somehow. You are absolutely right. Loudness and intensity are related through a relation that is known as the Weber-Fechner relation. This relation states that loudness represented by L is equal to K times log I. Here K is a proportionality constant and I is the intensity, and L stands for the loudness. Now you will be interested to learn that intensity is an objective quantity. That is, it is the same for all human beings. But loudness is not an objective quantity because loudness depends on a person's hearing ability. A person with a hearing impairment will not be able to hear a particular sound as well as a person with no impairment might. So for that person, for those two persons, the loudness of a particular sound will not be the same, but the intensity of those two sounds will remain the same. Now we studied that sound can be classified on the basis of loudness and intensity. Are there any other factors to classify sound? Let us find out. Let us listen to an audio clip.
Hello. Hello. Hello.
Now let us listen to another audio clip.
Information, how can I help you?
Now tell me what you heard. In these two audio clips that you heard a sound that was deep and you also heard a sound that was shrill. Now the sound that was shrill had a higher pitch and the sound that was deep had a lower pitch. These were the sounds of a man and a woman's voice. Now do you think this pitch can be used to classify sound? You will be interested to learn that pitch of a sound is dependent on its frequency. How does the pitch depend on frequency? Let us find out. When we have a high pitched sound, you will notice that the sound is more shrill. In the previous case, when you heard the audio clip that had the woman's voice, that sound was more shrill. That is because it had a higher pitch. And if a sound has a lower pitch, it will be more flat, as was the case with the man's voice. Now what do you see over here? When the frequency is higher, the pitch is higher. That is, with higher frequency, the pitch increases. Accordingly, when we have a lower frequency, we have a lower pitch. That is, the sound becomes more flat. So if we increase the frequency, we increase the pitch and the sound becomes more shrill. And if we decrease the frequency, we decrease the pitch and the sound becomes more flat. Now tell me, we learnt about pitch being dependent on frequency, and we also learnt about loudness and intensity and how it was related to amplitude. Now I will play the sounds of two female singers. Will you be able to distinguish between these two sounds? Before you do so, let me tell you that these two singers have the same loudness and the same pitch.
लग जा गले हंसी रात लग जा गले के फिर ये हंसी रात हो न हो.
So how can we distinguish between the sounds of these two singers? We can distinguish these two sounds on the basis of timbre or quality. What is the quality of sound? Quality of a sound is the characteristic by which we can distinguish between two sounds having the same pitch and same loudness. So if we are to distinguish between the sounds of two singers who have the same pitch and same loudness, we do so with the help of quality or timbre. Now notice these two pictures that are shown. These two pictures represent waveforms that are emitted by two different instruments. It will be interesting for you to learn that these two waveforms correspond to the same note being played on the two instruments. For the first case, this is a note being played on a flute. And in the second case, it is a note being played on a violin. Now you will notice that both these waveforms have the same amplitude and same frequency. So how are we able to distinguish them? We are able to distinguish these two on the basis of their waveforms. So what can we say? We learned previously that we can distinguish between two sounds of same pitch and same loudness on the basis of quality. And here we find that we are able to distinguish these two on the basis of their waveform. Thus we can conclude that the quality of a sound is dependent on its waveform. So let's take a quick recap of what we learned. We learned that all sounds that we hear around us are not the same. They can be distinguished based on certain factors. What are these factors? The first one that we learned was loudness. Loudness was related to the amplitude. That is, greater the amplitude of a sound wave, more was its loudness. Lesser the amplitude of a sound wave, lesser was its loudness. Then we learnt about pitch. If we had a high pitched sound, it meant it had a higher frequency. And if we had a low pitched sound, it meant it had a lower frequency. Lastly, we learnt about quality. That is the factor which enabled us to distinguish between two sounds that had the same loudness and same pitch. So we learned that quality was dependent on the shape of a sound wave or the shape of the wave.